Okay, so this tutorial is a continuation from last tutorial, and we got to speed things up this tutorial because we have a lot to talk about. So let's get right to it. If you took the challenge last tutorial, then here are the answers, and I will post them very quickly so you can see if you got them correct or not. The first line of output was hello there with 2 exclamation points. The second line of output was so this prints a line with the number 2 and a question mark. The third line of output was and line 3 with a comma and with a beep and a period. If we actually ran this program, it would actually make a noise, but we didn't, so let's not worry about that for now. Okay, so back to the lesson. Any computer program must use a data type made up of numbers, characters, and/or words. Programs process that data into meaningful information. Inside your computer is a bunch of memory. The memory holds the operating system, your program as it executes, and it also holds your program's data. See Figure 2.1 below. Figure 2.1 is a representation of memory and addresses. Memory can be thought of as a series of cubbyholes all lined up in a long row. Each cubbyhole or memory location is numbered sequentially. Every memory location has unique address. To do anything useful in C, you need to define variables. A variable is just a named place in memory that can store a value, a number, a character, or a word. For you, when you define a variable, C finds an unused place in memory and associates a name to that memory location. That way, the programmer can simply use the variable name to access the location and does not need to know the actual address in memory where the value is stored. See Figure 2.2 below. In C, any variable you must use must be defined first, as C needs to know what type of data you are storing and therefore how much space to allocate in memory. How can I choose the correct data type? Let's see. Different data types take up different numbers of bytes in memory. Programmers typically choose the data type that can store the complete range of values anticipated for a variable, using the least amount of memory possible. The flowchart in Figure 2.3 below can be used to help you choose the appropriate data type. For now, we're just going to walk through an integer like 2. So let's start. Is the number an integer, a whole number, or either positive or negative? Yes, it is. So let's drop it down. Is the number between negative 32,768 and positive 32,767? Yes, it is. So use an integer. As you can see, this flowchart is a good resource for finding the appropriate data type for the value you're trying to store in a variable. Please pause the video if you would like to read more about data types, and actually give this a nice glance because it will give you the appropriate ranges that will allow you to store what values into what data types. Unfortunately, I don't have time to go over this with you in this tutorial. However, feel free to pause and rewind. Table 2.1 and Figure 2.4 below show the amount of space typically allocated for various data types. Please give them a glance. Pause the video here if you'd like to look at them any further. Here we're going to try an exercise. So use the drop-down box below beside each value to select the most appropriate data type. Try to select the smallest data type that could store the value specified. Review Table 2.1 or the flowchart in Figure 2.3 if necessary. So I'm just going to run through this quickly for us. Population of Toronto, long, average bank profits, double, let's check if our answers are correct. Yes, our answers are indeed correct. Let's move on to the next example. Many programmers use a double for all decimal values. Due to the extra precision for a double, It's more appropriate to use than a float. For this reason, we do not often see the float data type in programs. In order to define a variable, you will also need to choose the appropriate and legal name for a variable. Here are some of the standard variable naming conventions and rules shown in Table 2.2. Please give them a glance. Pause the video here if you would like to read them any further. C is case sensitive. In other words, uppercase and lowercase letters are considered to be different. A variable named student with a capital S is different from student with a lowercase s, which is different from student in all capitals. Many programmers use all lowercase names simply because they are faster to type. Variable names continued. Examples of legal variable names are shown below. Please pause the video if you'd like to take a further glance. Go now to the exercise on the next screen to test yourself in recognizing legal variable names. For each of the variables below, use the drop-down box to select from the list of reasons why the variable is illegal. So I'm going to run through this quickly, and please look at the answers. This contains an illegal symbol, which is a space. And we're going to check our answers, and they're all correct. So before we get on to defining variables, I just want to go over what you're actually going to need and the tools that you'll actually be using to be creating our programs. I'm going to do that in the next tutorial. You guys did a great job today, and I'm looking forward to writing some code with you in the next tutorial. Thank you.